Hi, in this video I'll demonstrate how to regenerate the Haskell package set that's included in the Nix Packages Collection. If you want to follow along, then you will need a working installation of the Nix Package Manager. Beyond that, you won't need anything else. I will run the entire update in a newly created Docker environment to ensure that the whole process is easily reproducible for other people. The Nix project provides a ready-to-use Docker image that's based on the Alpine Linux base image and has the Nix Package Manager installed on top of it. The image is very small and contains almost nothing except for Nix itself. Therefore, we'll have to install a few things that we'll need. Most importantly, a shell that supports some form of completion. Furthermore, we need the Cobalt install utility and of course the Haskell compiler GHC. Now that we have an environment in which we can compile Haskell source code, we just need the source code. We check out the source code of the Cobalt to Nix utility directly from GitHub. When regenerating the Haskell package set, it's recommended to always use the latest version of that source code. There is of course a Cobalt to Nix and a Hecate to Nix utility included in the Nix packages distribution. But these are not always the latest version, and oftentimes the Git version has changes that have not been published yet because they concern mostly developers and not end users of the utility. For what we are trying to do, however, we are developers and we always want the latest version. After installing Git, we need to find a place where we can check out the source code. In this particular example, I created a directory called /work in which I'll do all of that, but basically the location doesn't matter. You can use whatever is convenient for you. Now we have to clone 3 repositories. First of all, we need the Cobalt to Nix utility. The next repository we need is that of the Nix Packages Collection, because that contains the files that we want to regenerate. The last repository is called all Cobalt hashes. That is basically a copy of the Hecate database that's been imported into Git. Personally, I find it kind of difficult to remember the URL where that is located, but fortunately it's very easy to find out whenever you need it. All you have to do is show the log messages of the Hecate packages file in Nix. And the commit message always mentions the URL, because it records which revision of that repository was used to generate the current version of the Haskell package set. The all Cobalt hashes repository contains 2 branches, and curiously enough the master branch is not the one we are interested in. We are interested in the branch Hecate, which is the one that contains all the Cobalt files and the corresponding hashes of the release tarballs for each version. Now, the generator expects that this repository is located inside of the Cobalt to Nix repository under the name Hecate, so we just move it into that place. Similarly, the generator expects the Nix Packages repository inside of the Cobalt to Nix repository under the name Nix Packages. The next step is to compile Cobalt to Nix. This can be as simple as running Cobalt build, obviously, but it's gonna take a long time because we'll need a lot of dependencies to have this package built. Instead of compiling everything from scratch, we can use Nix to generate a development environment for us in which we can easily compile the package. There are 2 ways to accomplish that. The first approach is to use the information that is contained in Nix packages already. Every Haskell package exports an environment which can be used to compile that very package. Cobalt to Nix is no exception, and we can easily enter a development environment that can compile Cobalt to Nix. The good thing about this approach is that it is extremely simple to do, and it will work 99% of the time. However, the build instructions for Cobalt to Nix that are found in a current version of Nix packages may not necessarily match the build instructions one would need to build the development version. If we want a build environment that definitely matches the development version, then we have to generate the Nix expression from the Cobalt file that we have in our development version, and to do that we need Cobalt to Nix. At first glance, this looks like an infinite recursion. But what we're doing really is to use a release version of Cobalt to Nix to generate a Nix expression which can then build the development version of Cobalt to Nix. So everything is fine. Unfortunately, when we try to use the newly generated Nix shell environment, it turns out that there is a problem. By default, the generated expression considers everything that's found in the current directory to be a part of the tool's source code. And that includes two very large Git repositories that we checked out and copied into that directory. Now, those repositories are not part of the source code, and they are way too big to let Nix copy them into the temporary build sandbox, which is typically located on a memory-backed file system like /tmp. If we were to actually try and run that build with Nix, chances are that it would just run out of memory. We have to edit the generated expression to remedy that problem. In particular, we need to extend the definition of the source attribute so that it contains information about paths that are to be ignored. At last, we can enter the Nix shell environment that we wanted all along. Inside of that environment, a simple Cabal build, or rather Cabal new build, will just succeed. The only thing that could stop us now is the fact that the wget binary we have in path comes from the Alpine Linux distribution and not from Nix. Alpine ships a version of wget that comes from BusyBox and does not support the input file command line flag, which Cabal apparently needs. Installing the Nix version of the tool should solve that issue. At that point, it suddenly occurred to me that I wanted to install the NSLOOKUP executable as well. I had this vague recollection that Cabal install needed that too. I'm not sure what for. I think it uses it to find the closest mirror of the Hecate database before downloading that. Anyhow, it seemed innocent enough when I thought about it, but then it turned out that finding the package that contains that program is actually much more difficult than I thought it would be. Anyhow, eventually I wound up with a functioning Cabal install, and now the environment is able to compile Cabal to Nix. The build result consists of two executables, Cabal to Nix and Hecate to Nix, and the latter one is the one that we are interested in. When run, Hecate to Nix performs the following tasks. First of all, it lists the known packages in the current version of the Nix Packages Collection. This is necessary because Haskell packages may refer to system libraries or even system executables, and by scanning those that we currently have in Nix packages, we are able to satisfy those dependencies automatically most of the time. Furthermore, the Nix Packages repository contains a file called configuration hackagetonix.yaml. That file is mostly concerned with version choices. Obviously, there are many different versions available of each package on Hecate, and it's not always obvious which version we would like to choose. This config file plays a major role in that decision. This config file is also the place which defines which builds are known to be broken. Then there is the Hecate Repository. Cobalt to Nix reads the entire Hecate database and determines for every package which versions are available. By default, we include only the latest version in Nix Packages. This choice may be altered by the configuration file though. The last piece of input is a file called preferred versions. That file determines which versions of which packages are considered obsolete. Hecate needs a mechanism like this one to retract releases, since it does not allow deleting something that has been published on the site. Unfortunately, the all Cobalt hashes repository does not contain one preferred version file, it contains hundreds of them. There is basically one for every package that has published some kind of preferred version range. The Hecate to Nix utility expects us to deliver one such file, so we have to invest the manual effort of concatenating the many files into one. Before we do that, however, we have to make a choice about the version of the Hecate database that we would like to generate our package set from. Obviously, we could just use the latest version and that would work fine. But for the purposes of this demonstration, it might be nice to reuse the exact same version of Hecate that was used to generate the package set that we currently have. If we run the generator from the same Hecate version again, we can expect the output to be identical. In other words, our Nix package repository shouldn't show any changes. And if that works out, then we know for sure that the command we are running does the exact same thing as the official generation process. The version of Hecate that our Haskell package set in Nix was generated from is pretty easy to find. The official generator records the appropriate Git ID in the commit message of the Hecate packages file every time it pushes an update. Therefore, a quick look at the Git history of that file will tell us the commit ID that we want. Once we have reset our Hecate checkout to the appropriate commit ID, we can concatenate the preferred version files into one. Unfortunately, this cannot be done with a single call of cat because the individual files are not necessarily terminated by a new line. This means that we have to use a slightly more involved for loop that adds the new line after every file to the output. Now we can finally run the Hecate to Nix generator, and we can do so without having to specify any command line arguments because all the required inputs are in their default location. The tool will typically run for about half a minute, and the result of that generation process should be no changes to the Nix Packages repository, because we simply regenerated what we already had. Since that test was successful, let's run Hecate to Nix again, and this time we'll use the latest version of Hecate. That should give us some updates. The Cobalt to Nix repository contains another script that is quite useful. It's called update stackage. The script downloads the latest version of the LTS Haskell package set, which is basically a large number of version recommendations for Haskell packages. The script will then merge those version recommendations into the configuration file for Hecate to Nix. The effect is that the next run of Hecate to Nix will generate a package set that conforms to the appropriate release of LTS Haskell. These version choices are encoded in a section of the script that is called default package overrides. Basically, any package version that is listed in this section will be preferred over the latest version, which we would choose by default. As always, the Hecate to Nix generator has to be run to make the changes in the configuration file take effect in the actual Nix package set.